Good morning students. Welcome back to Pushdown Automata. So in last video we was discussed about how to construct pushdown automata for different types of languages. So in this video also we will discuss how to construct PDA for the language type of a power I, b power j, c power I plus j, otherwise a power m plus n, b power m, c power n. So here first of all we discuss about how to construct PDA for this particular language a power I, b power j, c power I plus j. So already we know whatever the simple logic for construction of push down automata. So from the given language, so we can derive some string. From that particular string we can identify what is the midpoint, so that means the middle of the string. So up to middle of the string, first part of the string we can perform the push operation, and second part of the string we can perform the pop operation. So here the given language is a power I, b power j, c power I plus j. So here I comma j is may be considered as either greater than 1 or greater than or equal to 1 or greater than 0, any condition. Why? Because here doesn't specify. In case specify, then we can choose only from that particular condition only. So for this we can assume either I comma j is greater than 1 or greater than or equal to 1. So then here clearly we can identify when we read, when the string contains I number of a's, j number of b's and I plus j number of c's. So that means here number of a's and number of b's is equivalent to number of c's. So clearly we know when read number of a's we perform the push operation. After completion of a's we can read number of b's, then we can perform the push operation. After completion of b, when we read c's, then we perform the pop operation. Why? Because here a can occur I number of times, b can occur j number of times, c can occur I plus j number of times. That means total number of a's and b's is equivalent to number of c's. So that's why when we read any number of a's, I number of a's and j number of b's, then perform the push operation, and when we read I plus j number of c's, then we perform the pop operation. So that is the logic for constructing push down automata for this particular language. So that's why when read number of a's we perform the push operation, and number of j's number of b's also we perform the push operation, and when read I plus j number of c's, then we perform the pop operation. So now we consider IDs for instantaneous description for this particular language. So just now we assume when read, once again when read any I number of a's, that means any number of a's, perform push operation, and read any number of b's, then also perform the push operation. After that when read number of c's, then perform the pop operation. So to construct push down automata or to developing the IDs for this language, so clearly when read any number of a's from some specific state, after completion of a's only b can occur. So that means once b occur, never a can be allowed in that particular language, in the given language. So that's why after completion of a's we can change the state. That means when read I number of a's, we can perform the push operation, and when read b, change the state and then perform the push operation, and any number of these perform the push operation from here. After that when read c, change the state and perform the pop operation. So why we are changing the state after completion of a's and after completion of b's means once a is completed and b started, then a never allowed. So that's why in case we are using the same state for push operation of a's and b's, then there is a problem. So in case string is like as a b b a, so it was also allowed to performing the push operation. That's why we change the state after completion of number of a's and after completion of number of b's. So that's why. So here we are starting with the initial state q naught. So in our given language must be starting with a, so that's why there was no need to take initially input symbol as b. Why? Because a power I, b power j and c power I plus j. So that's why I number of a's occur. After completion of I number of a's, then only b's can occur. After completion of b's, then only c's can occur. So that's why by initially we can read only input symbol a only. So that's why we, and initially top of the stack is empty. So here empty stack is indicated by z0. So that's why when read this combination from current state q0, input is a, top of the stack is z0. So that's why we perform push operation and then go to next state. Why? Because this combination can occur only one time. At first time only this combination will occur. So top of the stack is empty. So that's why we perform the push operation and go to next state. So in case here we are not changing the state, then after that either after reading the first input symbol as a, from next time onwards this combination never occur. So that's why here loop is not good one. So giving the loop to q0 itself is not good one. Why? Because this combination can occur only one time. So that's why, so perform the push operation and then go to q1. So here a z0, that means here a was pushed into the stack. So and then move to next state q1. So now from q1 we read any number of a's and top of the stack is a. Why? Because already we perform one push operation. That's why top of the stack now contain a. So when we read any number of a's from the q1, we can perform the push operation. So it can go into the same state. Why? Because here any I number of a's can occur. So that's why it can give as loop. So that means going to the same state q1. So after completion, in case third symbol is also input, in third input symbol is also a, then also we are considered from q1 state. Input is a, obviously top of the stack is a, then going to the next state as q1 and perform the push operation. In this way I number of a's can be performing the push operation and then go to the same state. After completion of number of a's, when we read first b from q1 state, then top of the stack is a. So then we perform the push operation and then go to next state. Why? Because in case here also we are going to q1, then next in case a can occur, then obviously it can performing the push operation. But as per given language, after completion of once b occur, then never allows the a. So that's why we change the state to q2 and performing the push operations for any number of b's. So from q2 we read the second input symbol as b, then top of the stack is b. Why? Because previously we push b into the stack. So that's why here top of the stack is b. Then obviously we perform the push operation. In this manner any number of b's can be perform push operation and then go to same state q2. After completion of j number of b's, then we can read the input symbol c. So already we discussed at the beginning analysis session. So here when read the c symbol, then we perform the pop operation and then go to next state q3. In case we are not going to q3 and going to q2, then it was very mistake. Why? Because once c occur, never allows the a's as input symbol, never allows the b as input symbol. So that's why we will change the state. So here when read input symbol as c, going to next state, and here obviously top of the stack is b. Why? Because recently we performed the push operation of number of b's, j number of b's into the stack. That's why top of the stack is b. Then we perform the pop operation. So repeat the same process. We can and then go to next state. So from q3 input is c, top of the stack is b, then perform the pop operation. Here epsilon indicates pop operation and then go to same state q3. So here we can perform pop operation for j number of b's with the combination of input symbol c. When read c, j number of c's, we can perform the pop operation of j number of b's from the stack. After completion of these b's pop from the stack, next top of the stack is a and input symbol is same c. So now we can perform the pop operation and then go to next state q4. Why? Because once the top of the stack is a occur, then no chance to occur in the top of the stack as b. Why? Because first we perform the push operation as number of a's, after that number of b's. That means top of the stack contains number of b's. After that, when read C, we are performing the pop operation. That's why first number of B's will be popped from the stack. After that, number of A's will be popped from the stack. That's why from Q3, when read input symbol as C, top of the stack is A, then perform the pop operation and then go to next state. So from Q4, we can perform pop operation for any number of A's from the stack. So here we read number of C's from the Q4 and on top of the stack is A, then perform the pop operation and then go to same state. After completion of number of C's and input is completed, then end of the input is capital del and stack is also empty, then going to the accept or Q5 next state. Here Q5 is the final state. So these are the instantaneous descriptions for constructing the pushdown automata for A power I, B power J, C power I plus J. Now we observe pushdown automata diagram for this particular language. So from initial state, when read input is A, top of the stack is Z0, perform push operation. After that, we can perform any number of A's into stack, that means any number of A's, push operation. That's why input is A, top of the stack is A, then perform push operation and then go to self. So here I number of A's can be, first A can be pushed into stack and go to Q1. From here remaining A's can be pushed into stack. So after that, when read B, after completion of A's, when read B and top of the stack is obviously A, then perform the push operation and then go to next state. So from here we can perform the push operation for number of B. So that's why input is B, top of the stack is B, then perform the push operation and then go to the same state. Here J number of B's can be perform push operation. After completion of B's, we read the C as input symbol. So here recently we perform number of B's into stack. That's why top of the stack is B. So and then we perform the pop operation and then go to next state. From here number of B's will be popped from the stack when read input symbol as C and then go to same state. After completion of number of B's from stack, pop from stack, then we read the input symbol is C and top of the stack is A. Then also we perform the pop operation and then go to next state. From Q4 we can perform the pop operation of number of A's from the stack when we read input symbol is C. So after completion of these number of A's from the stack and number of C as input symbols, then we read the input symbol is del, end of the input. Here obviously top of the stack is Z0, then no operation and then going to accept, final state. In case here other than Z0, then it was not accepted. So this is the pushdown automata diagram or pushdown automata for the given language. So now we perform some tracing or some simulation of the input string from the given language. So here the given language is A power I, B power J, C power I plus J. So let I equal to 2 and J equal to 3. So that is our choice. You may be assume I equal to 3 and J equal to 5. Otherwise I equal to 5, either J equal to 1. That is your choice or our choice. So here I was assume let I equal to 2 and J equal to 3. Then the derived string is A power I, that means A square, B power J, that means B power 3, and C power I plus J, 2 plus 3, that is C power 5. Then the string is 2 A's, 3 B's, 5 C's. So from here when read number of A's, perform push operation and B's also perform push operation. When read number of C's, perform the pop operation. Why? Because here number of A's and B's is 5 and only number of C's is 5, both are equal. So that's why when read first part of the string, we perform the push operation. When read second part of the string, we perform the pop operation. So now we consider this example as input. Consider from the initial state Q0 and empty stack. So Q0 is the current state, input is A and top of the stack is Z0. So this is the combination of Q0, A, Z0. So perform push operation and then go to Q1. So that's why from ID1 perform the push operation, that is A will be pushed into stack and move to next state Q1. So now current state is Q1. This A is already completed, that's why we consider from here second A. So this A already pushed into stack, that's why we consider from second input symbol A, and remaining 3 B's, 5 C's, end of the input is del. So previously we performed the push operation into stack, that such element is A. So that's why now top of the stack is A and current state is Q1 and input symbol is A. So this is similar to in current state is q1, input is a, top of the stack is a, perform push operation. So that's why from id to perform push operation, that means a will be pushed into stack and move to same state q1. So here go to same state q1. Next we read the next input symbol, that is b from q1. So here in next current state is q1 and this a is previously pushed into stack, that's why remaining is 3b's 5c's, 3b's 5c's as the input. So now current input symbol is b. So out of this we are reading currently input symbol is b. So q1 is the current state, input is b, top of the stack is a. So this is similar to this one. From q1 state, input is b, top of the stack is a, then also perform the push operation and then go to q2. So that's why here we mention push b into the stack and move to next state q2. So now we are in q2 and remaining input is 2b's and 5c's. So that's why here from q2 state we read the next input symbol is b and top of the stack is b. So then we perform the push operation. So this is similar to this one. So current state is q2, input is b, top of the stack is b. So we perform the push operation. So that's why here we are, so from id4 we perform the push b. So that means b will be pushed into stack and move to same state q2. So in state q2. So next symbol is also b. So that's why from q2 input is b, top of the stack is b, then perform push operation, that is this one. Input is, current state is q2, input is b, top of the stack is b. So perform push operation and then go to same state. So now current state is q2 and input is c. So 3b's are already pushed into the stack, that's why remaining input is 5c's. So here currently we are reading first c and top of the stack is b. So which is similar to the q2, input is c, top of the stack is b. So we perform the pop operation and then go to next state q3. So that's why here we mention from current state q2, input is c, top of the stack is b. So that's why we perform the pop operation and then go to q3. So from q3 next input is c. So this one, next input is c and top of the stack is b, and then we perform the pop operation. So that's why here we perform the pop operation and then go to next state q3. So next input symbol is also c, but here top of the stack is still b. So that's why we perform the pop operation and then go to next state. So sorry, same state. So now already 3b's was popped. So first b, second b, third b was popped. So that's why for next current state is q3 and input is c and top of the stack is a. We will observe in next slide. So current state is q3, current input is c, top of the stack is a. So that's why we perform the pop operation of a. So that means pop a from the stack and go to next state q4. So here, so which is similar to this one. So current state is q3, input is c, top of the stack is a. That's why perform pop operation and then go to q4. So from q4 next input symbol is c, top of the stack is a. So then perform the pop operation and then go to same state. So from q4 input is c, top of the stack is a, perform the pop operation and then go to same state. Now so this one is complete, remaining is end of the input, top of the stack is z0. So current state is q4, input is end of the string, that is capital del, and top of the stack is z0. So which is similar to q4, input is del, top of the stack is z0, then no operation and then go to q5. That means where q5 is the final state, that's why that particular string is accepted by the pushdown automata. So this is the process of how to constructing the pushdown automata for the language a power I, b power j, c power I plus j, and then performing the simulation or testing or tracing for the some example. So at the same way, now you can consider some assignment problem or some homework problem. Construct a PDA for the language that recognizes the strings of type a power m plus 1, b power m, c power n. So that means here number of a's is m plus n times. Here a's can occur m plus n times and b's can occur m time and c's can occur n times. So that means when read m plus n number of a's, perform the push operation, When read m number of b's, perform the pop operation. When read n number of c's, then also perform the pop operation. Then stack will be balanced. For example, m equal to 2, just example, n equal to 2. Then a can occur 2 plus 2 times, that is 4 times. B can occur 2 times, C can occur 2 times. So 4 A's, 2 B's, 2 C's. Then when read 4 A's, we perform the push operation. When read 2 B's, we perform the pop of 2 A's from the stack. When read 2 C's, we perform the pop from 2 A's from the stack. Then finally stack is empty. So that's why the language is accepted. So these are the details about how to constructing the push down automator for this type of languages. Thank you.